All right, good afternoon, guys. This is Miss Scott coming to you from my room at some undisclosed location, here to talk to you today about acceleration and what that means. This video is meant for my physical science class, but it may be a help to you in whatever endeavors you are venturing upon at this moment in time. Alright, so let's get started with what the heck is acceleration? What is acceleration? Why is it important to know? How do I find it? That's a great question. All of those are good questions, and we're about to answer them. So the definition that I like to use for acceleration is the rate at which velocity, please note I said velocity, the rate at which velocity changes. So how quickly are you changing how fast you're going? You accelerate in one of three circumstances. You are either A, speeding up, you're making your velocity bigger. You're number two, slowing down, you're making your velocity smaller. You're stopping, slowing, whatever. Or number three, because this is the rate at which velocity changes, remember velocities are vector values. They have both magnitude and direction. It matters which way you're going. You're changing direction. So say you're in a car and you're on one of those little on-ramps to get on the interstate or off the interstate or whatever. Because you are changing direction, even though you might be going the same speed, because you are changing direction, you're going this way, then that way, then this way, then that way, then that way, whatever. That's a change in acceleration. For right now, for this video, I'm just going to focus on the first two things, when you're slowing down and speeding up, how to find those, and how to find those variables within that formula. It would help if I gave you the formula. The formula that we're going to use for acceleration is acceleration, is equal to your VF, or final velocity, how fast you end up going, minus your initial velocity, how fast you were at the start, all over time. How long did it take to go from point A to point B? Or to get from speed A to speed B, I should say. Some you may see it written in your classes or in other textbooks where A is delta V over delta T. Delta just means change in, so the difference in your velocities over your difference in time. It's the same thing. So if you see that, please don't be intimidated by it. It's just this. Alright, so I want to spend this video, ladies and gentlemen, I'm going to move this over just a teensy bit. I would like to spend this video doing a couple practice problems and showing you how I approach problems. I feel as a teacher, what I experience is people, what I experience is people students having difficulty not in the math itself, but seeing lots of numbers in an equation, or lots of numbers in a word problem, and just starting to plug them all in, not really understanding what that number means. So that's my reasoning behind doing the steps that I'm about to do. It might seem arbitrary for you, it might seem silly at first, but it is a really good strategy for any problem that you approach, that you know what you're looking at first. Alright, so alright, 15 MPH. Pardon me as I write this. Alright, so my first problem. I have a car speeding up from 15 miles an hour to 60 miles an hour in a total of 4 seconds. So what I do with these problems, and if you are one of my students, this is what I have you do. You need to do this on your assessments and whatnot, is I'm going to say, okay, what do I have? What do I have? The formula, and we'll write the formula up here. I need to know what of those variables I have and what I don't have. So I'm going to make my little chart. This takes you, no joke, like 5 seconds. Okay, that was maybe like 7 seconds. You have 4 variables. The only way you can solve one of these problems is either you have 3 and you're only missing 1. If you're missing 2 or more, you need to A, go back and reread the problem. Maybe there's one hidden in there somewhere. Or B, it's not solvable. Probably A. Alright, so I go through my question. A car speeds up from 50 miles an hour to 60 miles per hour in 4 seconds. So most of these numbers are going to be important. Let's look at those first. From 15 miles per hour. So I was at 15 miles an hour. That means that is my initial velocity. So I'm going to write 15 mph here. Alright, my next number. From 15 miles per hour to 60 miles per hour. So I'm going from 15 to 60. 60 is my end point. 60 is how fast I end up going. I need to know that. That's my final. VF. In a total of 4 seconds. That seems really silly to say this out loud, but you should anyway, because what harm is it going to do? 4 seconds, that is how long it took. That is your change in time. And please note that when I'm making these, I'm putting my units in here. That's going to help me when I plug it into the formula to see what I need to report at the end of my problem. So, I have 3 variables. I'm missing only 1. That means I can work with it. I need to find my acceleration. So I'm going to go ahead and erase that. Next step, plug it into your formula. Okay, leave A as is because you don't know what it is yet. Equals VF minus VI over time. Okay, my VF is 60. And please be careful. Again, I've seen a lot of students do this at all different levels of physics and all walks of life. Just because this is a bigger number doesn't mean it's always the F. A lot of people want to put the bigger number here. It's not always going to be that way. In this case, it is. In some cases, it won't be. Make sure you're putting the F there and the I on the other side. Minus 15 mph over 4 seconds. Okay, so go ahead and take a second to solve this while I solve it with you. So here we just need to simplify the numerator. You can subtract these two things because they have the same units. You can subtract miles per hour from miles per hour. So 60 minus 45, and I should know that is 15. That's me being silly. And I'm going to change how it's written from mph to mi over hr because it's going to make my reporting units a little nicer looking, I guess. Over 4 seconds. It should go without saying, but I'm going to say it anyway because maybe it's not familiar to you. That's okay. We don't leave an answer like this. This isn't simplified. I know when I see an answer like this, I say, what does that mean? I don't feel like doing the math. I already wrote this test. I don't want to write the answer keys. So simplify it. Always, always, always simplify it. So type in your calculator, 15 divided by 4, and that gives you 3.75. 3.75. What am I going to report this in? This is why I changed this to mi over hr, miles per hour. You have miles per hour up here and seconds down here. Those aren't the same. They can't cancel out. So you have to keep them all together. So what I'm going to do, and I have just enough space, it's going to be miles per hour per second. So basically what that means is for every second that I'm traveling, I'm getting 3.75 miles per hour faster. That's all that means. So with acceleration, you're always going to have 3 units. You're going to have a distance over a time over a time. It just depends on what you're given in the initial problem. Alright, let's do another one. I'm going to redraw my chart, as should you. And I'm going to say let's say a snail moving at 3 meters a second slows down to half a meter a second, and this whole change in velocity takes 2.5 seconds. Alright, so I'm going to go ahead and fill my chart in first. What do I have? What don't I have? A snail moving at 3 meters a second. It was moving at that. That's its initial velocity. So that's my VI. 3m/s. Slows down to 0.5 meters a second. Slowing down to that speed. That is the speed at which it arrives at. Or ends up going. 0.5 m/s. Meters per second. And that whole thing takes 2.5 seconds. My time, 2.5 s. Alright, so that leaves me with one thing not known. That's great, I can work with that. Let's plug it into the equation. I like to write the equation down in its unsubstituted form in my problems, because that way I see all the little details in it. Some equations that we're going to use have squares and square roots and all that other stuff. And if you forget that little detail, you're going to get the wrong answer. It's good practice. It's good habit. So I don't know A. VF. So here's an example where my VF is smaller than my VI, which is okay. And that actually worked out very nicely. Alright, so 0.5, go ahead and solve that on your own. Go ahead and pause the video if you need to. Alright, and I actually didn't intend the numbers to work out this nicely, but they did. So when you subtract 0.5 from 3, you get a negative number. That just means this thing is slowing down, which it says in the problem, so that's right. So negative 2.5 meters per second over 2.5 meters per second, you know if you divide something by itself, the answer you get is going to be 1. My units, velocity, is meters per second over a time per second. 1 meters per second per second. You can also write this when you have 2 time units and they're the same thing. You can write it as 1 meters over second squared. That would be an acceptable answer as well. It's the exact same thing as this stuff. So, I'll wrap this video up. Go ahead and comment if you have questions. I'm going to make another video shortly on how to find other variables that are not acceleration. So time, velocity, final, velocity, initial. Please be on the lookout for that soon if you're in my phys sci. And until then, happy science.